Hi everyone. In this lecture, I will go into the details of each microservice and component and explain the technologies, tools, and patterns that you will be using in this course. On the left bottom, you see the tools that you will be using in your environment. You will use Java 11, IntelliJ as your development environment, Maven as your dependency management tool, Git as the version control system, and finally Docker for containerization of your services, as well as running the dependencies like Kafka and Elasticsearch locally using Docker Compose files. In the first microservice, Twitter to Kafka service, as the name suggests, you will get the data from Twitter and put on Kafka. In this section, you will start learning the basics of Spring Boot, as well as the basics of Kafka. You will run a Kafka cluster using a Docker Compose file and learn the Kafka concepts such as brokers, partitions, and topics. Kafka topics are the units that host the real data, and you can think of a Kafka topic as a folder in a file system and think of the logs or events as the files inside this folder. You will be using Spring Kafka to implement our Kafka producer, which will be responsible to write the data on a Kafka topic. You will also learn our schema type, as you will use it for our Kafka models, and you will use Kafka admin dependency to create our Kafka topics programmatically, and check if the Kafka topics are created prior to running microservices. You will also integrate the logging framework Logback, which is so easy thanks to Spring Boot auto configurations. Finally, in this section, you will use Twitter4j library, which is a Java client library to stream the data from Twitter. As you will see, while writing your first microservice, you will already be starting to create a modular architecture to reuse the modules across all projects. And at that point, I will also introduce the first microservices pattern, externalize configuration, to externalize service configurations. You will use Spring Cloud config dependency and define a Git repository locally and push it on GitHub to manage it remotely. You will then implement security for your configuration endpoint, as well as encrypting your secrets using JSIPed and also with Java cryptography extension in separate lectures. Then you will continue with the second microservice, which is Kafka to Elasticsearch. Here you will dig into the Kafka consumers, along with Spring Kafka consumer implementations, to read data from Kafka and put the data on Elasticsearch. At that point, you will first look at the Elasticsearch basics and the index API of Elasticsearch, as you will need to use indexing operations to put the data on an Elasticsearch document. To run Elasticsearch cluster locally, you will use a Docker Compose file, again as was in the Kafka cluster. You will see different ways of querying Elasticsearch from Spring, using Elasticsearch templates and Elasticsearch operations and repositories, and see how different level of implementations can make the developer life easier. However, at the same time, it will take the elasticity of writing complex Elasticsearch queries. Then, having the data on Elasticsearch, you will start writing Elastic Query Service, which will be responsible to query the Elasticsearch, and it will be your third microservice. In that section, you will go into the details of a web application using Spring Web. You will be implementing Hey to Us, adding controller advice for catching unexpected errors and exceptions, adding API versioning for your endpoints, and adding OpenAPI documentation to your APIs, where you will be using Swagger as the implementation. Finally, you will be learning Elastic Query API and look at various query types that Elasticsearch offers. At that point, you will also write an alternative reactive query implementation of the service to be used by the later sections. Note that by implementing this service and separating query parts, you will already be implemented the CQRS, Command Query Responsibility Segregation pattern. Here the query component is query service, and the command component is the first microservice, Twitter2 Kafka service, which was originally creating the data on our event store Kafka. After that, it will be time to write a web client called Elastic Query Web Client, which will have a basic front end to call your previously created Elastic Query service. And this will be again a separate microservice. At that point, you will learn Spring Web Client to call a microservice using REST API and learn TimeLeaf along with Bootstrap to create a simple front end. You will also add the reactive web client components, which will use the previously created reactive service component, so you will have a separate section that will show a complete reactive example. Finally, you will add a simple client-side load balancer to your web client, where you manually set the load balance instances. Note that we will replace this later with automatic load balancer when we integrate service discovery into our application. Following, you will add the key cloak authorization server into the picture and implement OAuth2 and OpenID Connect protocols for your Elastic Query service using GWT as the token type and using Spring OAuth2 resource server and client dependencies. In this section, I will also show how KeyCloak helps us to implement a single sign-on solution. Then you will start learning Kafka streams by writing the Kafka Streams service as a microservice. Kafka streams are really helpful if you want to change a streaming data and create another stream from that, and you will be doing exactly the same by adding a new calculated or aggregated column to your previous Kafka topic and write the result to another topic using Kafka streams. You will also be creating an in-memory state store from the Kafka streams, which can be queried using a REST endpoint later. You will call this REST endpoint from the query service to get the calculated data. You will use the new Kafka topic created in the Kafka streams section to create a new microservice, which is called Analytics service. This service will simply consume the data from the newly created topic, which actually contains a new analytics column, and you will put this data to a relational database in this section, where I will introduce open source PostgreSQL database and Spring Data to implement this part. I will then show how to effectively insert the data to PostgreSQL using Spring Data JPA and batching. Then it will be time to implement our service discovery to register and discover services by using Eroka. In this section, I will also show how to make discovery service high available. Then I will put the API gateway solution into the picture with the Spring Cloud Gateway. In this section, you will implement client-side load balancing, circuit breaker and fallbacks with Resilience4j, and rate limiting with Redis, and apply these patterns to the services running in our architecture. Note that this section will require running a Redis instance, and again, I will be using Docker to run and use it. Coming to the end, you will add monitoring capability to your services by using Spring Boot Actuator, Prometheus, Micrometer, and Grafana for creating dashboards for various metrics. Finally, you will implement the last piece, which is log aggregation and distributed tracing, where you will be using ELK stack, Logstash and Elasticsearch along with Kibana for visualization, and also using the Spring Cloud Sleuth and Zipkin for tracing of the application. At this point, you will be implementing and using log aggregation and distributed tracing microservices patterns. And on the right bottom, you see the microservices patterns that you will implement in this course as summarized. I know it seems a lot at first glance, but you will see how easy it will be when you develop it piece by piece as modules and put the correct tools for organization of your microservices and components. Alright, let's kick off this journey. I will see you in the next section.